All right. Hello again, everyone. So we're checking in today on our 5.13 RSG notes, and we're learning another method to solve a system of equations. So after solving them by graphing, and then most recently solving by substitution, now we're using a third method, and it's solving using elimination. You'll sometimes also hear this method called combination. So if you ever see solve a system with combination, you know it's the same thing as what we're doing right here. So we're going to take this step by step and go through the steps over here while solving the problem over here. So first, make sure all of the terms are lined up vertically. And what that means is when you take your two equations, remember system of equations is two or more linear equations, we're going to line it up so like the x's are over the x's, the y's are over the y's, the constants are over the constants. It works really well in standard form. Ax plus by equals c and ax plus by equals c. Everything lines up perfectly. So then examine the coefficients. Remember, those are the numbers that are connected to the variables, like the -3 right there or the 2 right there. You want two of the coefficients to cancel. Now, they're going to cancel each other if they are the same or opposite. This is when we can get numbers to cancel each other, is when they're either the same as each other or opposite from each other. So I notice here, for instance, that -2 for this y up here and +2 for that y down there, they're opposites of each other. It has to be from the same variable. It wouldn't help me if a -2 right here and then if there was a +2x, because y and x don't go together. That's why we line it up vertically. So I look at -1, -3. They're not the same. They're not opposite. That's not going to help me. But I see -2y, +2y, opposites, and that means I'm going to be able to cancel them. Well, how do I cancel them? I combine the two equations together. And how I actually do that is add or subtract. And remember, it's all about trying to get these to cancel. So if you have a -2 and a +2, opposite numbers will cancel when you add them together. So I choose to put a big plus sign kind of right next to these equations, and then I'm going to draw a line like as if I'm doing an addition problem. So let's go ahead and do that. We're going to combine the two equations together. And if I slip my 1 in right there, this becomes -1 plus -3, that's -4x. But then when I do -2 plus +2, -2y plus +2y, they cancel. It makes 0y, or just cross them out. And then on the other side here, I have -12 plus -12, that's -24. So once you get one of the variables to cancel, because the coefficients were either the same or opposite, you'll see there's only one variable left now. So you can solve for one variable, and very easily, since one of them canceled, just divide by -4 on both sides, and we get x equals 6. Now we know a solution to a system of equations is an ordered pair. We need an x value and a y value. So finally, step 5, use the value from number 4 to solve for the other variable. So if I know x is 6, I want to know, well, what does y equal? Now, none of these equations up here say y equals whatever, so it's going to take a little extra work, but basically I just go back and I pick one of them. It does not matter which one you pick. So either the top equation, -x minus 2y equals -12, or the bottom equation, -3x plus 2y equals -12. It doesn't matter which one. I'm just going to pick the bottom one. But again, you could have chosen the top, and that would be fine as well. And now I'm going to use the value from number 4, the variable I solved for, and I'm going to use it to find the other variable. So now that I know x is 6, then I put it back in one of the original equations. So -3 times x becomes -3 times 6. Everything else stays the same. -3 times 6 is -18. And you can see at this point we're able to solve for y if we continue. So do a plus 18 on both sides. And we get 2y equals -12 plus 18 is 6. Divide by 2 on each side, y is 3. So there's an x value, there's a y value. Let's finish by writing it as an ordered pair. This is 6, 3. And remember, that means if I graphed these, right, if I went back to these original equations and put them on a graph, this line and this line would intersect each other at 6, 3. So let's go ahead and practice that a couple more times. So down here we have another example, and now I'm kind of going to just talk through those steps and go a little quicker. So is everything lined up vertically? Yes. X over x, y over y, constant over constant. So let's check the coefficients. Are any of them the same or opposite? And I see 2x and negative 2x. They are opposites. So since they're opposites, I'm going to combine the equations, get them to cancel using addition. And 2x plus negative 2x cancels. 3y plus 5y is 8y. 11 plus 13 is 24. So now I can solve for the variable that's left. Divide by 8 on each side. Y equals 3. And now I can use that value to find the other one by substituting it back into one of the original equations. Remember, it does not matter which one. So I'm going to choose 2x plus 3y equals 11, but you absolutely could use the other one. It wouldn't make a difference. Make sure you substitute into the right place. Since y is 3, I replace the letter y with the number 3. And from there I can solve. 3 times 3 is 9. And then I'm going to do minus 9 on each side. So 2x equals 2. And then a divide by 2 on each side. Finally, x equals 1. So there's an x value, there's a y value, 1, 3. Ordered pair, final answer. Since we've done two problems like that were very similar to each other, where both times I chose to use addition, I'm going to go ahead and skip number 2 up here. It's ultimately very similar. I see negative 4, I see positive 4. They are opposites. I would choose addition again. You can try that one if you want, but it's very similar to the 2 that we just did. I'm going to go ahead and skip it for now. Oh, I did forget to point out, sorry, right back here, check your solution. You check this the same way we did with substitution, and that's once you have x and y, you put them back in each equation. So now I go to 2x plus 3y equals 11, and I replace x is 1, and 3 times y is 3, and 2 plus 9 does equal 11, so that one worked. And then I checked the other one, and that was negative 2x plus 5y equals 13. That's negative 2 times 1 plus 5 times 3 equals 13. That's negative 2 plus 15 equals 13. Also true, so I know it works. So checking the solution, same here as it was for substitution. That's take your ordered pair, x, y, and check each equation one at a time. Replace x, replace y, make sure it all fits together. Do it again, and if you get a double yes, then you know you've got a good answer. So again, back over here, we're going to skip number 2. It's very similar to the ones we've done so far, and move ahead to number 3. So the reason I wanted to make sure to check number 3 is it is a little different. Everything's lined up, x over x, y over y, constant over constant. I look to examine the coefficients. I want something to cancel. I know they cancel if they're the same or opposite. So 4x, 5x, nothing the same, nothing the opposite. But now 3y, 3y, both positive. They're the same as each other. So whereas the last couple examples we had opposite values and we got them to cancel using addition, now if you have values that are exactly the same as each other, you can get them to cancel using subtraction. So you put a big minus sign in front of that this time. Now it's everything on top minus everything on the bottom. So use this each and every time. It's 4x minus 5x. You're going to get negative 1x right there. When we do 3y minus 3y, anything minus itself cancels. And all the way over here, this is 2. And I come over here to use my minus sign. It's 2 minus negative 2. Ultimately, if you have to write some scratch work down to help yourself see it better, 2 minus negative 2. Well, once I see that it's minus a negative, I know I'm actually adding them, and 2 plus 2 is 4. So that's 4x minus 5x is negative 1x, 3y minus 3y cancels, 2 minus negative 2 is positive 4, and the equals in the middle. At that point, we can solve for x with a divide by negative 1 on each side. X is negative 4, and then remember, you can pick either of the original equations. So I'm using 4x plus 3y equals 2, and I can check if I think x is negative 4, then drop it right in there. 4 times negative 4 plus 3y equals 2, and 4 times negative 4 is negative 16, and then I can add 16 to each side, and finally divide by 3 on each side. I get y is 6. And there's my ordered pair. That's x comma y, negative 4 comma 6. And again, we're going to check that by taking each original equation and replacing x with negative 4 and y with 6. So 4 times negative 4 is negative 16, plus 3 times 6 is 18, and negative 16 plus 18 equals 2 is true. And one more time, this time the bottom equation, 5x plus 3y equals negative 2. That's 5 times x is negative 4, plus 3 times y is 6. 5 times negative 4 is negative 20. 3 times 6 is 18. And negative 20 plus 18 does equal negative 2, so that one works out. And now we're going to wrap up with example 4. Practice this one more time, because 3 and 4 are very similar to each other. So once again, I see everything lined up, and once again, I see some of my coefficients are the same as each other. A positive 2y right there, a positive 2y right there. So this is another chance for us to use subtraction. Again, note back in our original example, when they were opposites, we used addition. And again, in example 1 down here, when they were opposites, we used addition. But then starting with problem 3, whenever we saw coefficients that were the same as each other, we chose subtraction. And that's exactly what we're doing again right here. So top equation minus bottom equation. That's 7x minus 5x is 2x. 2y minus 2y, anything minus itself cancels. And 25 minus 21 is 4. So from there, a very simple equation to solve. Divide by 2 on each side. And we get x equals 2. Now I'm going to go back and choose one of the original equations. Remember, it does not matter which one you choose. Substitute x is 2 back into that problem. And 5 times 2 is 10. And then do a minus 10 on each side. And finally, a divide by 2 on each side. Now you'll notice that doesn't divide nicely, 11 divided by 2. So you can leave it as 11 halves. You can write it as a mixed number, 5 1/2, or you can actually do 11 divided by 2. You'll get a decimal answer. 5.5. So it's all good either way. And this is a great example of why graphing isn't always the best option. If the point of intersection 2, 5.5, it's not at a perfect whole number, we would have seen it was in between 5 and 6, but we might not have known it was exactly 5.5. We would have just had to kind of estimate and guess. So to quickly check that solution and wrap this up, original equation, 7x plus 2y equals 25, and that's 7 times x is 2, plus 2 times y is 5.5, 7 times 2 is 14, 2 times 5.5 is 11, and 14 plus 11 does equal 25, so there's one, and I'm going to go over here for the other. That's 5x plus 2y equals 21. 5 times x is 2, plus 2 times y is 5.5. And 5 times 2 is 10. 2 times 5.5 is 11, and sure enough, 10 plus 11 does equal 21. So I know 2 comma 5.5 is my answer. So that's it for today. If you could take a picture and upload pages 64 and 65, your 5.13 notes. That's all. Thanks, everyone.